Good morning and welcome back to my channel PT Rad Academics. Today we are going to discuss on generations of CT. CT means what? CT, the word CT you have always heard about CT scans, right? CT scans are computed tomography. The word CT means computed tomography and tomo means slices. So you have bought the bread from a bakery and sliced bread. Likewise, we are taking slices or cross section of our human body. So in the before classes, I have described about positioning terminologies. In that, I have discussed about different body planes. So the CT deals with the transverse plane. More about the components of CT I will be discussing in next sessions. Today I am dealing with only the generations of CT. So briefly I am saying the components of a CT. The more detailed version of the class will be seen in the upcoming topics. So here you can see an X-ray tube. Here X-ray tube. So the mode of beam we are using in CT scan is also X-rays. Then we are having filter. You can see here filter. Filters are used for shaping the X-ray beam by absorbing the low energy photons in order to reduce the skin irradiation or in order to reduce the skin dose. Then you can see here collimators and detected array, and all those things are the components of a gantry. This all comes inside a gantry. So X-ray tube is there, filter is there, collimator is there, detected array is there, as well as a gantry. Since the development of a very first CT scanner, so the CT scanner was developed at 1970s, the industry has seen a variety of changes applied to the CT scanner instrumentation, leading to the evolution of 7 different generations of CT scanners. Each generation of CT scanner is unique and varies based on the arrangement of the X-ray tube and detectors and how they move in relation to one another. So we are having 7 generations of CT, and CT was discovered in 1970s, around 1972, and it was discovered by Godfrey in Hounsfield. So we are moving on to the different generations of CT. The first generation is known as original EMI scanner or first generation CT. It is otherwise known as transit rotate CT. So here the detectors. When the case of first generation CT, there was only one detector. The type of beam was a pencil-like X-ray beam. The tube detector movement was transit rotate, and it was only specially designed for the evaluation of the brain, and the duration of the scan was average. It was about 25 to 30 minutes. So detector was only one detector, pencil-like X-ray beam. Transit rotate was the movement of the tube detector movement, and it was designed so the time it's a evaluation only for what, for the brain. It was only meant for the brain, and the duration of the scan was about 25 to 30 minutes. So you can see here the X-ray tube as well as the detector. There was only one detector, and the linear movement you can see in the figure how it was linearly moving. After one completion, the X-ray tube is rotating. Okay. So the first CT scanner was only for head scan and used a rotate transit system with a single X-ray beam called a pencil beam. The beam was a pencil beam. In order to produce such a narrow beam of X-ray photon, the first generation scanner used a pinhole collimator. The collimator was pinhole to ensure only a single beam of X-ray was interacting with the patient. Only a single beam of X-ray was interacting with the patient. Now you can see a figure. The figure is not clear. Then also you can understand from this figure. The gantry moved through two different types of motion, one linear and the other rotatory. As I discussed, linear movement and rotatory movement, transit, rotate. The linear motion was repeated over and over 180 times. Between each of these 180 linear movement, the gantry rotated 1 degree. So, each of these was how many linear movements? 180 linear movements, and after completing 180 linear movements, the gantry rotated 1 degree from 0 to 1 degree. Thus, the total rotatory motion encompassed a 180 degree semicircle. The axis of rotation passed through the center of the patient's head, that you can see here in this image. The X-ray beam will be on throughout the linear movement. When it is moving linearly, the X-ray beam will be on, and when it is rotating, the X-ray beam will be off during the rotatory movement. So the total number of transmission measurements was the product of the number of linear measurements 160 and rotatory steps 180, which was 28,800 in the original EMI scanner. So this is what happening in the first generation CT. The major disadvantages of the first generation CT was time. Time was the main important disadvantage of the first generation, since to scan a particular area it was only meant for brain, but for a particular or a single patient or for a single scan it takes about 25 to 30 minutes. So the major drawback of the first generation CT scanner was the amount of time it took to acquire the images and to reconstruct the images using the computer. This process was very demanding in terms of both time and manpower. Again, moving on to the second generation CT, it is also known as transit rotate, same name as that of first generation CT, but it is different from that of first generation, since from a single detector the detectors have increased to multiple, that is up to 30 detectors. Around up to 30 detectors will be there. The type of the beam changed. From pencil beam it has been changed to fan shaped X-ray beam. And the tube detector movement is same as that of first generation itself, transit rotate, but instead of moving 1 degree at the end of a linear scan, the gantry rotates through a greater arc up to 30 degree. So in the first generation I have said you that there will be linear movement. Linear movement will take about 160 steps. After completing 160 steps, the X-ray tube will be rotating 1 degree. Likewise, the X-ray tube should rotate up to 180 degree. But in this case, the linear movement is there. Okay. but the X-ray tube is rotating to a greater arc up to 30 degree. So somewhat the scan time have reduced. So the duration of the scan is average is less than 90 seconds. The largest advantage associated with the second generation CT scanner was the substantial decrease in acquisition time compared to that of the first generation. This generation of CT scanner was measured to be 15 times faster than the first generation. Here you can see an image, you can see the X-ray tube as well as the fan beam along with the detector. So this much area is covered with a fan beam. Again we are moving on to the third generation CT, rotate. The name changes from translate rotate to rotate. So the detectors is multiple. It has also increased. Multiple. Originally it was about 288. Newer ones is having around 700 detectors arranged in an arc. So in a third generation CT, this third generation CT is now termed in another way as conventional CT. Here the detector number have increased to from 30 to around 700 detectors, and here we are using fan shaped X-ray beam, same as that of second generation, but the fan beam width have been increased. So that much area. So the single slice will be covering the whole area. Okay. Then the tube detector movement is rotate. The tube and the detector starts to moving rotate. That the linear movement have stopped. The duration of this scan average was approximately 5 seconds. So this is an image of a rotate scanner. You can see a patient lying on the couch. This is the X-ray tube, and the down you can see the detectors. Detectors are in the form of an arc, and the X-ray tube is covering a single slice. It is covering from this edge of the detector to this edge. You can see in this image clearly. The X-ray tube is picked up by a row detectors wide enough to image the whole slice. So the whole slice can be imaged. The two then rotate together to image a different angle. This is repeated until a single slice is scanned. The two then move the patient to start imaging a different slice. This is most commonly used method today and takes about 0.3 seconds to image a single slice. The peculiarity of this third generation CT is that when we are setting up the patient to the couch and when we are setting up, the X-ray tube and the detectors will be moving clockwise as well as anti-clockwise. For example, if we are imaging a CT brain, we will be covering from the area of interest is from vertex up to the base of the skull. If we are covering that much area and we are giving a 5 mm slice thickness, and we will be setting up a table index in this conventional modality, or setting up the table index, and once when an image is accurate, the table will be moving into the next slice position, and the tube detector will be rotating in the anti-clockwise direction. One clockwise rotation, one slice will be accurate, then anti-clockwise the tube detector system will be rotating and the another slice will be accurate. Likewise, clockwise and anti-clockwise rotation is happening in the third generation or in the conventional CT. Hope you understood third generation CT. This is another diagram of a third generation CT. The introduction and the wide aperture fan X-ray beam which would reach the entire patient slice at one time. This specifically was what eliminated transitional motion in CT. That means we have eliminated the linear movement. In the case of a third generation, the linear movement has been completely erased. The increase in the angle of the fan beam angle have increased. The increase in the angle of the X-ray fan beam require the introduction of a longer linear detected array. This new array consists of about 400 to 1000 detector elements. In order to facilitate the synchronous rotation of the X-ray tube and the detector, these two parts of the CT scanner were joined so that they would rotate together. So these X-ray tube and the detector is connected together. Both will be rotating clockwise as well as anti-clockwise. So when the detector comes down, when the X-ray tube comes down, the detector will be moving up, and anti-clockwise. When the detector comes down, the X-ray tube will be moving up. So in each rotation, the slice will be acquired. The third generation CT scanners have two major disadvantages. Firstly, the addition of 400 to 1000 detector elements is much more expensive than only using 2 to 30 detector elements. Secondly, the third generation CT scanner produces a characteristics image artifacts known as ring artifacts. Regarding the CT artifacts, we will be discussing in the upcoming topics. So just mentioning here that this ring artifacts is usually seen in third generation CT scanner, and these artifacts are produced due to large number of detectors and the lack of calibration that is often present between the detectors. Fourth generation or rotate stationary detectors. So first one was transient rotate. Second was also transient rotate, third was rotate, and the fourth generation is rotate stationary. Here the type of the beam is same as that before, fan shaped X-ray beam. The detectors have increased, it have become multiple more than 2000, arranged in an outer ring which is fixed detector. So the stationary is what? Detectors is stationary and the X-ray tube is rotating, and the tube detector movement is rotate fixed. The duration of this scan is average to about few seconds. So here you can see the image. A stationary detector is there and the X-ray tube is rotating inside the detector. Fourth generation scanners were developed specifically to evaluate the ring artifacts produced by the third generation. Specifically, the impossibility to have such a large array of rotating detector elements greater than 400 are perfectly synced and calibrated to one another in order to avoid these ring artifacts. Okay. By removing the detectors from the rotating gantry and putting them in a stationary ring around the patient, and the detectors were able to maintain calibration. This stationary 360-degree ring of detectors require an increased number of detector elements of approximately 5000 total. So the X-ray tube is rotating inside the stationary ring or array of detectors. So once again the images are shown here. Just a revise. X-ray tube as well as the detector. You can see the X-ray tube at the top and the detector at below. In the first generation, we are having only a single detector and we are using a pencil beam of X-rays. So the mode of beam in CT scan is also X-rays. And the linear movement is here. Once a linear movement have gone, the steps in a linear movement is about 160 steps is required to cover one linear movement. After 160 steps of linear movement, the X-ray tube will be rotating from 0 to 1 degree. Likewise, it will be rotating approximately up to 180 degree. So the scan time is more, about 25 to 30 minutes in the case of first generation. While in the case of second generation, the same linear movement is there, but instead of a single pencil beam, the beam has widened to as fan beam. Okay, and fan beam, and the detector is reading this fan beam. And after completing the linear steps, the X-ray tube will be rotating from 0 to 1. Like instead of rotating from 0 to 1, here it will be rotating up to 30 degree arc. Okay, so the scan time will be reduced compared with that of first generation. Again, moving on to the third generation, you can see the X-ray tube as well as the detectors below and the fan beam. You can see about 700 detectors will be there, and 360 degree rotation it is shown. You can see the arrow up as well as arrow down. That means clockwise as well as anti-clockwise it is moving. Continuous rotation is not possible in the case of third generation. It is otherwise known as conventional CT since it is of cable connection. So continuous rotation of the tube detector system is not possible in a third generation CT. While we are moving on to the fourth generation, you can see an array of detectors and the X-ray tube is inside the detector. Okay, and it is X-ray tube is rotating, so it is known as rotate stationary. Again, moving on to the fifth generation CT, electron beam CT, CBCT. So the X-ray source is not X-ray tube. Before, from the first to fourth, we were seeing that the X-ray tube. But here the X-ray source is not X-ray tube, but it is focused to a steered microwave accelerated electron beam. The electron beam, the production of the X-rays we will be discussing in the upcoming topics. So the electrons, when the fast moving electron hits the target, tungsten target, X-rays are produced. So EB means the electron beam. Okay. The electron beam which is generated is coming down. You can see in this figure, you can see the target and it is hitting on the target and the X-rays are produced from below. The patient is lying on the couch and the X-rays are produced and it is monitored by the detector which is seen up. You can go through the image. It has no moving parts. Everything is stationary. It is not having any moving parts. The target covers one half of the imaging circle and the detected array covers the other half. The scan time is less than 50 milliseconds. Sixth generation CT or the helical CT. This is the advanced one, helical CT, inaccurately called spiral CT. It is also known as spiral CT. Acquire data when the table is moving. Here we are getting a volumetric data of images. Here you can see the patient is lying on the couch. The table the patient lying is known as the couch. You can here see an yellow color, that is the X-ray tube, and the red color is seen as the detectors. And the continuous rotation of the X-ray tube and the detector is around this patient. And the table along with the table is moving. Okay. So continuous rotation of the tube detector system along with the table movement is happening in helical CT. So a volume of data is acquired. While in the case of third generation, as I said, we are setting up the table index as well as the everything we are setting up. Afterwards we are acquiring. When the X-ray tube and the detector is moving in one direction, we are getting one image on the screen. Afterwards the table will be moving to the next slice. When we press the exposure button, it will be moving in the anti-clockwise direction. So one rotation, one slice, second rotation, one slice, likewise slice by slice we are getting on the monitor. While in the case of a helical CT or the spiral CT, we are getting a volume data or volume of slices we are acquiring on the monitor. So the scan time will be completely reduced to seconds. Within seconds, the scan will be finished. So the helical CT or the spiral CT design is the X-ray tube rotates as patient is moved smoothly into the X-ray scan field. Simultaneously source rotation, table translation and data acquisition is happening. Produces one continuous volume set of data for entire region, data for multiple slices from patient acquired at 1 second per slice. Three technological developments. Why it is happening is that due to the slip ring technology. The slip rings are there inside the gantry which helps for the continuous rotation of the X-ray tube and the detector around the patient. Very high power X-ray tubes. Interpolation algorithm to handle projection data. Advantages of spiral CT: faster image acquisition, quicker response to contrast medium. Contrast medium we will be discussing later in the upcoming topics. Fewer motion artifacts, means motion the patient have a chance to move. So since the time is greatly reduced, the motion artifacts can be overcome. Improved 2-axis resolution, physiological imaging, improved coronal, sagittal and 3D imaging, less partial volume artifact. It is another artifact which we have discussed about ring artifact. Likewise, this is another artifact of CT. Artifacts also we will be discussing in the upcoming topics. 7th generation CT. It is a new technology to overcome the limitations of single row detectors. Hence it has multiple detector array. The collimator spacing is wider and more of the X-rays produced by X-ray tube are used in producing image data. For detector array, instead of single detector array, multiple detector array is there and it is MDCT. It will be discussed in the upcoming topics. So a comparison between a linear array used in other CT generations A and the multiple detector array used in the 7th generation CT is shown in B. Hope you all enjoyed the sessions and hope you all understood. Thank you for your patience listening. See you soon with the next topics. If you have liked my channel, don't forget to subscribe. Stay tuned for the next topic. Thank you so much.